this is part 2 of lesson 4.3a. So we'll continue with questions C through E and then do example 4. So we are trying to solve for variable k. We'll send all variables to one side, doesn't matter which side you choose. What I recommend is I'll send variables to a certain side and you retry the problem by sending the variable to the other side to see if you get the same answer as me, which you should. So in this case, I'll choose to send the variable to the left side. So I'll do 7 minus 2k. To send the variable to the left side, what I have to do is, just going to show you my thought process here, is 8 minus 5k. To get rid of the minus 5k, I need to add 5k. And so that means I need to add 5k to the other side, to the left side. Now I can simplify. I get 7 minus 2k plus 5k. It's 7 plus 3k. Is equal to minus 5k plus 5k at 0 is equal to 8. Now I can simply solve by doing 7 minus 7 plus 3k is equal to, since I took 7 away, I need to take 7 away on the other side as well. So that's 3k is equal to 1. Now I need to divide by 3 on both sides. The 3 cancels out over here since it's on the numerator and denominator. And we end up with k is equal to 1 over 3, 1/3. Again, retry that problem, but send the variables to the right side and see that you end up with 1/3 as well. Now we're going to try example C. I'll send all the variables to the left side this time, just to mix it up. You guys will try sending it to the left, to the opposite side. So I'll do 5 minus 3m. I'll get rid of the variable there by adding 3m is equal to negative 2, negative 2m, and then add 3m since you did it to the other side. Minus 3m plus 3m is 0, so 5 is equal to minus 2 plus m, because minus 2m plus 3m is m. Now I need to isolate for m, so I can do that by doing minus 2 plus 2 plus m. The reason I did plus 2 is to get rid of the minus 2 there. Since I added 2, I need to make sure that I add 2 on the left side as well. And so I get 7 is equal to minus 2 plus 2, which is 0, is equal to m. That's the same thing as saying m is equal to 7. So again, you're going to try this problem again, but you're going to send the variables to the right side instead of the left side. So now we're going to do example D together. It's the same process, except you need to make sure that you distribute first and simplify before you actually solve for the variable. So remember, use your distributive property rules that we learned. So we have 5y, because 5 times y is 5y, minus 15, because 5 times negative 3 is minus 15. So 5y minus 15. Then this has to be distributed in here, so it's negative y. That's like doing negative 1 times 1y, and then negative 1 times negative 2 is plus 2, is equal to 19. And then we can group similar terms and simplify. So we have 5y minus y minus 15 plus 2 is equal to 19. So that makes it 4y minus 13 is equal to 19. And now you can simply isolate for your variable as you would do any other example that we've done already. So we can do 4y minus 13 plus 13 is equal to 19 plus 13. That gives us 4y, because minus 13 plus 13 is 0, is equal to 32. And now we can divide by 4. So I'm just going to carry this problem out here. So 4y is equal to 32. Divide both sides by 4, because we want to unmultiply. We want to do the inverse operation of a multiplication. The 4's cancel out, because they become 1. So y is equal to 8. You can retry this process. In this case, we didn't have variables on both sides, so it doesn't really matter. The difference between this problem and other problems is that we had to use our distributive property in order to solve for y. For question E, we have to use distributive property, and we also have variables on both sides. So let's carry that one through. So first I'm going to distribute and simplify. So when I distribute this coefficient, this multiplication within the brackets, I get 4x, and then 4 times minus 2 is minus 8, is equal to minus 3 times 2x is minus 6x, and then minus 3 times plus 6 is minus 18. And now it's a simple solving for x by sending variables to one side and constants to the other. So I'll send the constants to the left side, and you'll try the same problem by sending the constants. I'll send the variables to the left side, and you'll try the same problems by sending the variables to the right side. So I want to get rid of the negative 6 here. That means I have to do plus 6. So I'm going to do 4x plus 6x minus 8 is equal to minus 6x plus 6x minus 18. So now I'm going to simplify. 10x minus 8 is equal to minus 6x plus 6x is 0, minus 18. And now I'm going to solve for x by isolating x. So I'll do 10x minus 8 plus 8 to get rid of the 8 is equal to minus 18. Since I did plus 8 on the left side, I need to do plus 8 on the right side as well. So 10x is equal to minus 10. And now I can do the inverse of a multiplication, which is a division. Divided by 10 here. Divided by 10 on the right side as well. The 10's cancel out because they equal 1 when you divide them, when you have a numerator and denominator. And so the end result is that x is equal to minus 10 over 10, which is negative 1. So now we're going to do a quick solve and check. This question here was actually already done in part C. We found that m is equal to 7. So we're going to do a left side, right side table to see that it actually is the correct solution. So we'll make our table like this. Left side, right side. The left side is 5 minus 3m. The right side is minus 2 minus 2m. And now we're going to replace our m by 7 on both sides to see if they will end up being the same. So 5 minus 3 times 7, and show all your steps like this. Minus 2 times 7. Then that's going to be 5 minus 3 times 7 is 21. And this is going to be minus 2 minus 14. 5 minus 21 is minus 16. And then minus 2 minus 14 is minus 16. So what we can see is that left side is equal to the right side. So what that means is, therefore, M, that meant to do therefore, 3 dots there, M equals 7 is the correct solution. So what we did is we substituted our solution that we found into both left sides and right sides, and we compared them to see if they were equal to each other. If they are, then yes, it is a correct solution to the expression that equates the equations. So you should go back and retry the examples that we did together by sending the variables to the opposite side that I did in this lesson and seeing if you're consistent with your answers. They should be. And then you can go back and try verifying each solution using left side, right side tables before you attempt all the homework that's assigned to you in your course outline.